Okay, so yeah, we're testing P. We want to see if it's greater than 55%, right? And so we left off on the null and alternative hypotheses. P is equal to 55% or it's greater than it. And so the next thing we have to do after we list our null and alternative hypotheses is we kind of have to pick a method. Are we going to use the critical value method or are we going to use the p-value method? And so here, since we're given p, which one am I allowed to use? The critical value method, p-value method, or both? Yeah, it's both. The only one that you're not allowed to use both for is when you have mu and when you have s and not sigma, right? So here it's actually both. And so I'm gonna do this problem both ways just to kind of show you the difference between them. If I don't specify, you can pick whichever one you are more comfortable with, but just be careful because I'm probably gonna specify which one I want you to use. As far as exams go, I'll talk more about that at the end, but you guys are going to have an exam the week after spring break, and it's going to be all chapter 8. So you should start preparing for that. I started making solutions. I'm almost done to all the practice problems that I posted online also. But so here, let's do 3. Oops. Let's use the critical value method. And so is this a right-tailed, left-tailed, or two-tailed test?
Right-tailed.
Yeah, it's right-tailed. And so I'm going to draw the curve. And so here, this is my critical region. What's the area of that piece right there? Yes, good job. 0.02, right? Because it's the area, the area of the critical region is the significance level, which is alpha. And so here I need to find this value, z sub c, oh geez, which is my critical value, right? And so here, how am I going to find that again? Which calculator function should I use? Speaking of which, where is my calculator? Yeah, it's the inverse norm one, right? And so, hang on, I have to scroll up, otherwise I'm gonna keep hitting my home button. So inverse norm, and then what area should I put in here, assuming that I don't have a fancy calculator? Like I have the TI 83 plus. Shoot. Yeah, it kind of keeps popping up for me too. Is it lagging for you, Emily? Try leaving and then joining again. That might work. So, Raf, it's not negative 100,000. You're kind of right to like, yeah, we do start over here, right? Because we do want to see everything to the left. But what we care about is everything like this piece, this area right here, which starts at negative 100,000, but that's not the area, right? And so what would, yeah, and so we want the area to the left. And so what is the area to the left here?
0.98.
Yeah, it's 0.98. And so in my TI 83 plus, when I do inverse norm, I'm going to put, here, put it in red, that 0.98 right there. And then 0, and then 1, because it's the standard normal curve. Okay, yeah. And then, can somebody actually do that real quick? I'm going to see if I can find my calculator. Yeah, I don't know where it went. Okay, there it goes. Okay, that's good.
I got 2.054.
Okay, I'll round that to 2.05. And so, yeah, that's the critical value then, is this 2.05. And so what would my critical region look like? So it's the interval notation part, and since it's right-tailed, remember it's gonna look like z sub c, and then what value is it gonna stop at? So it starts here, and it's gonna go all the way, not negative infinity, because it's right-tailed. So remember, right is always the positive part for like everything. So it's positive 100,000, it's positive infinity. And so here, we're gonna start at our critical value. That's where our critical region starts, which is 2.05. And then we're gonna go all the way, we're gonna never stop, basically. And so that's our critical region. What do I do after I find my critical region? So I'll kind of draw an arrow. So if you scroll back up to these first few pages, we're doing the critical region method. So I'm going to follow these steps, right? So I found the critical value. Now I need to find what? Oh, wait. This is the proportion. I'm talking about this one. Oh, wait a minute. We are testing a proportion. Wow. Okay, hang on. Can you guys still hear me? Nobody's answering.
Yeah.
Okay. Yeah, thank you. We need to find z, right? So here, z, which calculator function am I going to use to find z? Oh, there's a poll for that. Hang on. I got kind of excited about these polls. Oh, I don't think I can do it and share my screen though. That's kind of lame. That's really, oh no, I can. Okay, so go ahead and answer this question. Which calculator function, or which function in your calculator should you use? Can you guys see what other people are answering, or can you just answer?
You just answer.
Okay, thank you. I think for these polls, I'm gonna give a minute, and then after that, I'm gonna stop it. And so here, I'm gonna let it go for a little bit longer, just in case. So I'll give you guys like 10 more seconds to answer. There's 3 people that still need to answer. Okay, so a lot of people, the majority of the class said to use z-test. But remember z-test, and so I don't know, maybe it's because I accidentally pointed at the wrong one up here. But z-test is when you're testing mu, right? And so I'm not testing mu here, I'm testing p. And so, oops, I'm gonna use the instructions from testing a proportion p, which says to use this one prop z-test, right? A few people said to use t-test. It wouldn't be t-test. That's when you do not know sigma, right? So you're gonna use the t-test if you only have mu and s. I can't see who answered what. I can just see like the results and who answered. At least not yet. I can't see it. But yeah, so here we're actually going to use the one prop z test. So one prop z test. And so in your calculator, it's going to ask for, I think, I still can't find my calculator, but it's going to ask for P naught. And so what's P naught in this case?
0.55.
Yeah, it's that 0.55 that we used in the null hypothesis, right? It's the same one. And then it asked for X next, and we already found that. We found that on Friday, so 1098. And then it asked for N, which is 1800. And then it's also going to ask for either less than, greater than, or not equal to. And so here, we're going to use the symbol from the alternative hypothesis. So we would use greater than P naught, and then you just hit calculate. And so what value of Z are you guys getting? 5.12. So if we're using the critical value method, I'm going to compare this 5.12 to my critical region. And so is this critical value, or is this test statistic inside my critical region? Yes or no? Yeah, it is, right? So which is inside the critical region. And so when that happens, what am I going to do? And so the fifth step is to make a conclusion.
Reject.
Yeah, I'm going to reject because that 5.12 is pretty unusual, right? So I'm going to reject H naught. And I just realized I don't have room for the p-value method. We'll do the p-value method when we do the other problem, and then that way you can see both. But so here, the sixth one, that's to interpret the problem, right? And so since I'm rejecting H naught, I'm kind of accepting this, right? This like alternative hypothesis. And so I'm gonna have, there is enough evidence. And then here, I'm just gonna copy, not all of that, but I'm gonna copy this. To conclude, here, I'll put this in green. That way, you know, it's like the same exact thing, right? So style, green. Nobody's colorblind, right? Like red, green colorblind, because that would be annoying for you. I could change it. So there is enough evidence to conclude that the percentage of American adults, or of all American adults, who currently hold this opinion is greater than 55%. And so that's one way you can word it. Another way you can word it is you can say there's not enough evidence to say that it's equal to 55%, right? And so there's the whole problem. So do you guys have any questions about this problem? Does this make sense?
So we don't have to state alpha, like, in our conclusion? Like, I remember because last time when I was taking stats, like, last year, our professor would say, like, you're supposed to say, like, there is enough evidence to conclude that the percentage of all American adults at, like, the alpha level of 0.02 is
Yeah,
great.
I guess technically that would be better, right, than this. But yeah, you could add that. I'm not going to require you to though, because I hadn't really thought about that before. But yeah, here you could say at a 2% significance level. And that does like kind of help see the problem better. But what's it called? So one reason you might not want to include that, and you can include it if you want to or not, but one reason you might not want to is because sometimes like, and this is like real world stuff, and so it's not going to matter if you do it in this class or not, but if you're talking to somebody who doesn't know stats, they're not going to care what that significance level is, and so to them it's meaningless information. But if you're like talking to another person who knows stats, then yeah, you'd want to include that. And so it's just kind of like, who's your audience? Does that make sense?
Yeah, okay,
Okay.
thank you.
Yeah, you're welcome. But yeah, technically it is a little bit more accurate to put that there. So are there any other questions about this problem? I'm going to move on to the next one if not. Does everybody have it all written down? Like, can I scroll to the next problem? I can leave half of it up. This half. Okay, so here, this new problem says, are children heavier now than they were in the past? The National Health Examination and Nutrition Survey, published in 2004, reported that the mean weight of 6-year-old girls in the United States was 49.3 pounds. Another survey in 2012 reported that a sample of 177 girls, oh my goodness. And again, let's pretend this says random. Okay, so their mean weight was 51.9 pounds. The population standard deviation is 17 pounds. Can you conclude that the mean weight is higher in 2012 than in 2004? Use the alpha equals 0.01 level of significance. So some of these variables were already labeled for us. So, right, like this 17 is sigma. Here we have alpha is 0.01. Well, what is this 49.3 referring to? Yeah, this is going to be mu, right? And so that makes 51.9 which value or which variable? Yeah, this would be x bar. And so here, I have another poll for this. Oh, wait, no, I already asked it. Never mind. Okay, so here, the very first thing that we should always do is what? What's the very, very, very first thing I need to do for every problem?
State the requirement.
Yeah, the requirements. And so I'm going to have the first requirement is that it's random. And I wrote that in. The second requirement, since I'm testing mu, I don't need to make sure that those two values are greater than 10, but I need to make sure that what is greater than or equal to 30. N, yeah. And so you're going to have, is n greater than or equal to 30? Well, oh yeah, we forgot about this variable. So 177, so yes. And what this means is that I'm working with a normal distribution. And so, yeah, that's why we check for n is greater than or equal to 30. After the requirements, this is when you write your null and alternative hypotheses. And so here, my alternative hypothesis is H naught colon, and then what variable should I put there, mu or p? Yeah, mu. And what do I suspect, or what am I told that mu is equal to in the beginning? Oh, we already talked about that. It's 49.3. And then here, do I think that it's greater than, less than, or not equal to that 41 or 49.3?
Greater than.
Yeah, greater than. And so then the third thing that we're going to do, oh, okay, so here, which method can I use? The p-value method, the critical region method, or both? So you're both technically right, but you can use the other method that you didn't type as well. So here, because I'm given sigma, I can do either method, right? If I use z, well, okay, so yeah. In either case, I have to find the test statistic z, but I can do either method, like I can use either method. And so here, we're gonna use the p-value method. And so actually, let me make a little note. Can also use the critical region method, or the critical value method, whatever I was calling it. But then up here, I'll put a note, can also use the p-value method. Okay, so how does the p-value method start? What do I find first? And what am I going to use? So here, I'm going to launch this poll again. And so which calculator function am I going to use to find all of the stuff I need? Okay, so the majority of you got it right, but there's still some people confused about which test to use. And so here, I'm actually going to use z-test. So I think, did we write this down last time? Yeah, right here. If you look at all of this, right? If you're given mu and sigma, you can use the z-test. And so here, we're dealing with mu and sigma. Here, if you're not given sigma, instead you're only given s, that's when you use t-test. You only use one prop z-test when you're dealing with p, right? So the reason it's called prop is because p stands for proportion. And so this is actually talking about like this prop is like the p that you're actually using, right? And so that's kind of the summary of the tests. Make sure you know those because those are the majority of the problem, right? And so if you don't know which one to use, you're going to lose a lot of points on the exam because that's knowing this part of it is the most important part, because that's how you get the actual values that you need to make a conclusion. But so here, I'm going to use z-test. And when I use z-test to find all of this, okay, I'm not going to underline that. I want to find two values. I want to find p and I want to find z. And I think it gives you z first. But so what does it give you for each of those values?
For Z, I got 2.03. And for the p-value, I got 0.021.
Okay. So if I were to draw a picture of what's happening here. Okay, so you guys got the same answer. Cool. But so yeah, if I were to, excuse me, draw a picture here, what this essentially would look like is it's a right-tailed test. This value right here is no longer my critical value, so this is not the critical region, but this is my test statistic. And so the area of this part is 0.021. And so the fourth step with the p-value method is to make a conclusion. And so what do I compare my p-value to?
To alpha?
Yeah, you're going to compare it to alpha, right? And so here, alpha is equal to 0.01. So if I were to draw alpha on my picture here, then it's going to be smaller, like it's going to be a smaller piece than this piece because it's 0.021. And so here, this would be my critical region, right? And so this is alpha equal to 0.01. And just remember, so like it's a smaller number, which means it's going to be like a smaller picture, right? And so here, alpha 0.01, my p-value is greater than my alpha. So what is my conclusion? Reject or do not reject H naught?
Do not reject?
Do not reject. And then the last step is always interpret it. And so here, can you conclude that the mean weight of 6-year-old girls is higher in 2012? So I'm just going to kind of copy that. So there is not enough evidence to conclude that the mean weight of 6-year-old girls is higher in 2012 than 2004. And then, yeah, you can edit that piece at the 1% significance level.
I was about to ask the same thing. Her screen is off.
I have no idea what just happened. I'm sorry. It just, oh shoot, that's not what I wanted to share. Oh, hang on. It just completely, it kicked me out and then I couldn't go back. It recorded that whole time though. But so yeah, there's the notes. I'm sorry. I'm glad it didn't kick you guys out though. Oh man, the chat disappeared too. I think it cleared it for me. Okay, but yeah, so this example is done. Do you have any questions about anything? Does this make sense?
Yes.
Okay. So we only have 3 minutes left, but I'll scroll back up in a minute. But here, I kind of want you guys to do this one on your own and actually turn it in. So I'm gonna post something on Blackboard. I want you guys to do this one and just turn it in to me, just so I make sure you understand which test to use. But so here, yeah, we'll go over this one on Wednesday together. Like I'll have the answer here ready to go, and then you can just compare it. But so yeah, are there any questions about this example that we just did?
Nope.
Okay. All right, so I'm gonna stop this recording and then I'm gonna talk about, oops.